Whoa, oh, we're on. Mr. Trutna here. See? Mr. Trutna, right there. Okay, happy National Chocolate Covered Insect Day. This is Math 2, Unit 5, Worksheet 3. I am Mr. Trutna, and this is Worksheet 3, and on this particular worksheet, we are going to focus solely on rectangles. So we are going to do starting at number 10. So we're going to skip the first 8 problems and we're just going to pick up right at number 10 because we are focusing solely on rectangles. Number 10 lists 2 things that are true about the diagonals of a rectangle. Okay, well, the 2 things are the diagonals bisect each other. All right. And we got bisect each other. We got that fact or that property from the fact that a rectangle is a parallelogram. And the second thing that's true about the diagonals of a rectangle is that they are equal to each other. Okay? So there's the 2 facts about the diagonals of a rectangle. So numbers 11 through 12, it says Hij is a rectangle. Find the value of x and the length of each diagonal. Now, if you notice in number 11, and as the same goes for number 12, there is no picture involved or diagram involved. So what you want to do is, if ever you're doing a problem, especially when you're dealing with a shape, and the particular shape we are dealing with is a rectangle, and there's no diagram involved, you just want to draw a picture of that diagram. So let's start off this problem by drawing a rectangle. And you could draw any old rectangle you want. Just make the shape look like a rectangle. You're just using this for visual purposes. We're going to call it Hij. So one of the vertices we have to label as I. So I'm going to label the top left vertex as H, and then if I put H here, then the next letter I have to put is I. So this vertex has to be I, or this vertex has to be I. It doesn't matter which one. I'm going to call the top right vertex I, which means then this vertex has to be J. I'm just going in order, and this vertex has to be K. Alright, so this says find the value of x and the length of each diagonal. So what I'm going to do is I'm going to draw in my diagonals, okay, and I'm going to draw in diagonal H to J with a black marker, and then I'm going to draw in diagonal I to K with a red marker, and hopefully if you're watching this on home, on the line, then you will notice the different colors. Alright? So we have that, all right, and we know that H to J, so this entire black diagonal is 3x plus 5, and I to K, so the entire red diagonal is represented by 5x minus 9. Now I'm not going to write that 3x plus 5 in the actual diagram, or the 5x minus 9 in the actual diagram. It'll probably just confuse me, okay, but however, what do I know about the diagonals of rectangle? Well, we know that they're equal to each other. So what does that mean? Well, this means that H to J is equal to diagonal I to K. Now, H to J is represented by the mathematical expression 3x plus 5, and I to K is represented by 5x minus 9. Therefore, the equation that I would use to solve for x would be 3x plus 5 is equal to 5x plus 9. And then I'm going to do algebra now to solve this equation out for x. Okay? So notice I have a 3x to the left of the equal sign. I have a 5x to the right of the equal sign. So I'm going to go to the side that has less amount of x's, 3x, and I'm going to eliminate those first. So I'm going to subtract 3x's from both sides of the equation. Now when I do that, the 3x's would cancel, and I get a new equation that is 5 is equal to 2x minus 9, and now I'm just going to solve this. So I'm going to add 9 to both sides of the equation, and I get, the 9's would cancel out, so then I would get 5 plus 9 is 14. I'm going to work it out over here. Just ran out of room at the bottom, so I'm going to get 14 is equal to 2x, and then I'm going to divide both sides by 2. So therefore, x is equal to 7 for number 11. Okay, so the instruction said find the value of x, and I did that, so I'm going to put a check, and the length of each diagonal. Now I haven't done that. Okay, so I want to first find the length of h to j. Well, h to j is represented by 3x plus 5. I'm just going to write this in right here. But we just said that x was 7, so I'm going to substitute 7 for x. So that means h to j will become 3 times 7, which is 21, plus 5, so h to j is 26. All right, then we want to find I to k. Now, if I'm really thinking, I don't even have to do any math to find I to k. And why not? Well, we know that the diagonals in a rectangle right here are equal to each other. So if h to j is 26, that means I to k has to be 26 as well. Okay, so now the question is, do I trust myself to believe that? Well, I don't. So I'm going to check it out. Use math here. So I to k is represented by 5x minus 9. Okay, so then I'm going to substitute 7, which is x, in the place of x. So I get 5 times 7 is 35. 35 minus 9 is equal to 26. So you can see that it works out. Okay, so I'm going to put a check here because I found the length of each diagonal. Moving on to number 12, we have the same idea, and we're going to use the same exact diagram for number 12 as we did for number 11. Okay, that kind of worked out pretty slick, except for in this case, this particular problem, h to j, so that entire diagonal is 3x plus 7, the entire black marked diagonal, and then I to k, the entire red diagonal, is equal to 6x minus 11. So the equation that I'm going to use for x is going to be 3x plus 7 is equal to 6x minus 11. And then I'm going to solve this equation out for x. Okay, so I would take away 3x's or subtract 3x's from both sides of the equation. That would cancel out the 3x's, and we would get 7 is equal to 3x minus 11. My next step would be to add 11 to both sides of the equation. So then we would get 18 is equal to 3x. And then we would divide both sides by 3. Therefore, I would get x is equal to 6 in this equation. So we now know that x is equal to 6. Okay. Next thing I have to do is I have to find the value of x. Check, I did that, and the length of each diagonal. Okay, so let's find h to j. Well, h to j is represented by the mathematical expression 3x plus 7. We just found out that x was 6, so I'm going to substitute 6 in the place of x. So 3 times 6 is 18. 18 plus 7 makes h to j 25, and then I to k has to be 25 as well, and I'm going to trust myself because I know that because the diagonals in a rectangle are equal to each other. Okay, moving on to number 16. So number 16 says here that S to Q, see if we got it on the screen, there we go, S to Q, so this entire diagonal, which I'm outlining in red, is equal to 14. So I'll go ahead and put a 14 there, and I'll draw like that to indicate that S to Q is 14. For what value of x is parallelogram PQRS a rectangle? And then we need to find PT and find PR. Okay, well, so if you notice, we have PT here, which is represented by 3x minus 11. So we have PT. And then we also have SQ, okay, which is 14. Now, it would not be okay to say that P to T, which is just this little part right here, this part right here, is equal to S to Q. There's no way those are equal. All right, so to say that these two parts are equal would be inaccurate. All right, however, P to T, if you notice, since both diagonals are equal, and since both diagonals bisect each other, that means all four parts of the diagonals have to be the same. Okay, so if S to Q is 14, that means how long is it from P to T? Well, P to T would have to be 7. Why? Because half of 14 is 7. So to solve for, so this we would not do, to solve for x, we would say 3x minus 11, which is the representation of P to T, is equal to 7, which is actually what P to T is equal to. And I would use this equation to solve for x. So I would add 11 to both sides. That would make the equation for x, 3x is equal to 18. I would divide both sides by 3. Therefore, x is equal to 6. So there we go for x. Now we need to find p to t. Well, we already did that. P to t is equal to 7. Okay, then how about from p to r? Well, if p to t is 7, t to r has to be 7. So p to r would be 14. How did I get that? I went 7 plus 7. Okay, the next problem, number 19. Number 19 is we are dealing with a rectangle, and you will, whoops, let me pull it over here so you can see it. So you can see that this part of the diagonal right here, which I'm outlining in black marker, which I'll highlight in green, that part of the diagonal is represented by 9x minus 9. Then this part of the diagonal right here, which I'm tracing in red, is represented by 7x plus 11. Okay, so now remember, since this shape is a rectangle, the diagonals are equal to each other and they bisect each other. So that means each diagonal is cut into 2 equal pieces, but since the diagonals are equal, all 4 of those pieces have to be equal. So that means the equation that I would use to solve for x would be 9x minus 9 is equal to 7x plus 1. Solving this out, you would want to subtract 7x's from both sides of the equation. That would cancel out the 7x's, and then the new equation would be 2x minus 9 is equal to 1. Then using the inverse math operation of minusing 9, which is adding 9, we would add 9 to both sides of the equation. That would cancel out the 9's, and then we would get 2x is equal to 10. And then dividing both sides by 2, you can see that in number 19, x would have to be 5 to make this a rectangle. Okay, moving on to number 20, the next example. So number 20 says this is a rectangle. You can see that we are given that this angle right here, angle OMN, is 5x. And then we know that the measure down here, it's telling us the measure of angle PMN is 110. Okay, so angle PMN would be 110 degrees. So they're telling us this whole angle right here is 110 degrees. And the instruction said, I forgot to read the instructions, for what value of x is the figure the given special parallelogram. Okay, so we want to make this, figure out what x is, to make this parallelogram a rectangle. All right, now hopefully you recognize that number 20 is a trick question. Why is it a trick question, you ask? Well, look, angle PMN we're told is 110. Does anybody see a problem with that, with the fact that we want to make it a rectangle? Well, you should, because a rectangle, all the angles are 90 degrees. So this problem, number 20, is impossible to solve. There is no possible way that that shape, that right there, can be a rectangle. Okay, number 22. Now in number 22, you notice that we're told that we want the shape to be a rectangle, so it is a rectangle, and we're told that this angle down here is represented by 4x minus 12, and this angle right here is represented by x plus 2. Now remember, if a shape is a rectangle, that means that by definition, all the angles are right angles. So that means every one of these 4 angles is 90 degrees, a right angle. So that means the equation that I would use to solve for x in number 22 is 4x minus 12 plus x plus 2 would be equal to 90. Okay, that would be the equation. How do I know that? Well, that entire angle has to be 90, and these 2 angles add up to make that 90. Okay, so then I would solve this for x. So I would combine the like terms. 4x plus x makes 5x. Minus 12, there go the lights. Hold on. So minus 12 plus 2, well, that makes it a lot easier to see, is minus 10. That would be equal to 90. Adding 10 to both sides of the equation, I would, after the 10's cancel out, the equation would become 5x is equal to 100. Then, of course, you would divide both sides by 5. Therefore, x is going to be 20. So that would be your answer to number 22. The last problem that dealt with the rectangle was number 24. And if you notice in number 24, we're told that this shape is going to be a rectangle. And then we're told that this angle right here is represented by 2x plus 10. And then this angle right here is represented by 3x plus 5, okay? And we want to find the value of x. Now here's how we're going to do this one. This one's going to take a little bit of a thought process. What we're going to do is we're first going to focus in on this triangle right here. Okay, now I know this triangle, I know that all the diagonal parts are equal in a rectangle. Okay, the diagonals are equal and they bisect each other. So that means then that if you looked at this green triangle that I outlined in green, it has two equal sides, so it's an isosceles triangle. Okay, so why is that important? Well, it's important because if this angle down here, remember, so in an isosceles triangle, the two equal sides are called the legs, and the third side is called the base. So this side right here that my pen is running along is what is known as the base. And then the base angles which run along the base are equal. So these two angles right here are equal. Now that's important because if this angle is 3x plus 5, that means that angle right there also has to be 3x plus 5. And now if I combine that angle with this angle and the shape is a rectangle, that means that even though it doesn't look like it, this angle, you probably can't see that very well, right there has to be 90 degrees. All the angles have to be 90 degrees. So the equation that I'm going to use to solve for x would be the 2x plus 10 angle plus this angle, which is 3x plus 5, and that's going to be equal to 180. So there's the, 90. Whoops. So because that triangle is isosceles. Solving it out, 2x and 3x combine to make 5x. Positive 10 combined with positive 5 make positive 15. That's equal to 90. Subtract 15 from both sides of the equation. We would get 5x is equal to 75. Divide both sides by 5. X would be equal to 15. And there we go. Pull the curtains. The play is over.